Hello, everybody. We'll wait just a few minutes as people join. Welcome. Okay, I think we'll get started. Well, welcome everyone to our webinar, Hidden Patterns, How Curbside Data and AI Are Transforming Smart City Management. As cities grow denser, curb space is more valuable than ever, yet many councils lack real-time data on parking, enforcement, and turnover. So without clear insights, congestion worsens, revenues lost, mobility suffers. My name is Jonathan Engler. I'm going to be the moderator today. I'm a journalist and a researcher who's most recently studied innovation and worked across mobility in smart cities. And I'm very excited to have two experts who can help uncover these hidden patterns in our data. Ben Pish, the Vice President for Clients and Markets of Sensen, and James Barr, co-founder of Turnstone. I want to run us through the agenda quickly. It's fairly straightforward. It'll be a mix of presentation and then a panel discussion. We are very open to your questions. So at the bottom of your screen, you should see at the bottom right a Q&A submission button. We'll also be starting two polls that we would love your feedback on. And there's a chat participation questions box. Now, we brought Sensen and Turnstone together for this webinar to dig down into these hidden patterns because there's a complementarity between the two. With Sensen, in a sense that the curb face, the cold face of our cities, collecting the data, and Turnstone analyzing it. And without further ado, I would like to bring James up to introduce himself and dig in to our first range of the hidden patterns. Thanks, James. Welcome.
Thanks, Jonathan. As Jonathan mentioned, I'm James. I'm the co-founder of Turnstone. Turnstone is a software platform, for those who don't know, for parking teams in cities who need to make decisions more confidently or back up their decisions or explore their options with respect to the curb. And folks who understand the data is key to helping them do that. For my part, I spend a lot of time with the cities and the data. I talk to operators frequently. We look at data together. We think about how the curb works, especially for parking, how decisions are made, how paid spaces get used. And I've seen a lot and validated it with real leaders in parking who use that data to make real world decisions. So I'm going to share with you some things that blew my mind in this session. And firstly, not one city knows exactly how many parking spaces they have. Now, I say that with respect to the operators, but I think we all know it's actually true. How many spaces that were not closed, that had active working meters, that were not under construction, did you have at 3 o'clock yesterday? Every city's got a ballpark number for this, but how many spaces did you actually have? This isn't an insult, but it's reality. There's data there somewhere in some system, GIS tools or permit software, spreadsheets, but honestly, how long would it take you to figure that out? With every city I've worked with, it's a lot. It's so much effort, it's usually not going to happen. Imagine a restaurant for a second, and you're in charge of running it. So you've got a dining room, tables and seats and staff, and a kitchen with food costs and prep times you have to factor in. You might be measuring things like the best sellers, your highest margins, your total dollars, or maybe dollars per seat, and time spent by guests in those seats, or seats occupied at a point in time, the number of turns of your dining room, or the duration of stay overall, or your wait times of guests. If that sounds a lot like parking, it's because it is. Now imagine you're doing this in your restaurant and you don't know exactly how many seats you've got. You don't know the average time people are seated, or the wait times to get a seat, or the number of seats occupied an hour ago, or your costs or your margins. It would be, if you're missing all that stuff, it'd be impossible to run the business. And restaurants are already an impossible business. But restaurants manage this with a point of sale. They've got a system that tracks data and gives them reports daily, weekly, or monthly on all of those things: tables, seats, occupancy, spend, all in one place. The thing is, I don't know what just happened. On the Curb, there is no single point of sale. There's hundreds or maybe thousands of equivalent seats. There's dozens of data sources. And it's all kind of scattered and hard to pull together, but that data can be harnessed. And when it is, there's so much to learn to drive decisions. Another example here, I'll kind of share with you. A lot of people, including the late, great Donald Shoup, look at parking, especially on the Curb, as an issue of supply and demand. So the higher the price, the less demand there should be. So higher rates would mean lower occupancy on the Curb or in your lots. We thought so too. So we did a large study on this. Over 30 neighborhoods with more than 5 rate changes over several years. And then compared those rates against the number of vehicles parked. We'll call that demand. So here's an example. This chart is showing one neighborhood over that long period of time where rates fluctuated between $2 and $3. And yet somehow over this whole period of time, when rates were higher, demand went up. Maybe it's flat. It definitely didn't go down, which is a little odd. It's something we would have expected to see with higher rates, lower number of vehicles. So why? Do we have a definitive answer to this? Well, what do we know? People want to park close to where they're going, and parking can be hard to find, especially in a denser or busier environment like a downtown. If you find a spot and you park there, and then you notice the rate was 50 cents higher than last time, would you leave to save maybe $1 for your visit? I think probably not. But does this mean that supply and demand is not a thing? Well, it turns out that's not the full story. We dug deeper, thinking maybe vehicles parked is not the right measure of demand. So what else could we measure? The cost of parking is related to your location, obviously, but it's also related to the duration that you stay. So here's a graph of long-term duration for one neighborhood over a few years. First off, just what do we see? It's a bit spiky week over week. Maybe folks don't want to leave their car as long in January because it's cold or it's rainy or it's snowing. But generally, we see a couple trends over this 3 years. In 2022, it's fairly flat. Things are moving slightly downward. The length of stay, though, really dips through 2023 and then kind of bottoms out and rebounds slowly in 2024. So let me just overlay the timing of rate changes throughout this 3 years. So that's really interesting. We look at 2022, there weren't any rate changes. We have our sort of flat, maybe slight downward trend in the amount of time people are paying for, but we get to 2023 and rates went up by $1 per hour twice. And right in line, we see these large drops in duration that people are paying for. In 2024, and actually around the end of 2023, rates started coming back down, but slowly, 50 cents at a time over 4 successive changes. And what we see is a slower but visible upward trend again in duration. So what's happening here? We can make some educated guesses. We know people want to be close to their destination. We know that if people are already parked, they're probably not going to unpark themselves and drive around looking for another spot. But what can we change about our parking behavior after we're parked that still affects the cost? What's length of stay? At least that's what the data suggests. So there's a lot more we can do with this. Oh, sorry, Jonathan, did you want to?
Yeah, I just wanted to jump in there because when you said it was how could I say it, like a slight counterintuitive, it seems to me like it's a pretty major, maybe it doesn't rank as a discovery, but it feels like you've discovered something in the data that went against the way people perceive that. Were you surprised?
Yeah, this was, this really started on a hunch. We had been looking at data for years, thinking parking is supposed to be elastic in that when you raise the rates, you get less cars parked. People are not going to park. But this kind of came out of hey, we're not sure that elasticity is there. That graph that we saw earlier where the amount of cars parked maybe went up when the rates went up. And we started to think about the reasons why. And it certainly seems like, well, I mean, if I think about my experience, do I look up the parking rates before I drive? Nope, I don't. I just go where I'm going and then I park where I find a spot. And like, especially if I'm parallel parking, good luck, pulling out and doing that a second time successfully and not scraping my wheels on the curb. So I'm going to stay. And that's where we kind of threw a dart at the dartboard here. Just thinking, what about duration? Like, let's just see what it's data we have. Let's just see what we get. And we ran this graph and immediately saw exactly what I showed here on this previous slide. We saw this and went, okay, cool. Something's changing. And then we just started ballparking. We knew when these rate changes had happened. And we're like, hey, the first one kind of happened at the top. And then the next one happened on the way down. And then we went back and pulled the data and saw, yeah, not only did these time just right, but the size of the rate change seems to have an impact on how fast people react to it. So that dollar increase really seems to have pushed down the demand for, we're talking from 88 to 82 average minutes maybe, right? It's only 6 minutes, but that's on average for thousands of parking events. So some folks are cutting off 30 minutes because they just don't need to stay that long. And others maybe are still paying the same amount. So it was really interesting to see. Completely unexpected. It wasn't until we just said, hey, show me 3 years of data and let's see what we see, that it kind of popped up.
Yeah. And so one last, just to follow up on that, then it's like, to go back to your restaurant analogy, you pull back the curtain on the data and it shows the entire experience of what it's like to be in that restaurant, right? So to be at the curbside, it might not just be 1 or 2 levers. There might be an entire experiential piece there that we might be missing because we're actually missing that data.
I think you're absolutely right. Without the data, you're not going to see any of this. It's going to be hard to know. And you'll get anecdotes from people, but what does that mean when you're in a city of 100,000, 500,000 people, however big you are, and you have a handful of people tell you this is my experience? It's hard to know how far that stretches without this large collection of data. On top of that too, I think you hit the metaphor is right here. If you're running a restaurant, one of the things you're thinking about first off, you want good food and you want a good experience and you want people to want to stay. But then at some point you want people to want to leave so that other people can come in and they can have their food. And this would be so much like, finding the right price point in your restaurant to make sure that folks, come in and have their food and maybe they have their 2 beverages. And at that point they're going to go and they're not going to sit there all night and just take up that seat.
Yeah, exactly. And it's also that gentle nudge that, some restaurants have that they say, okay, this booking is for an hour, 2 hours, et cetera.
Exactly.
So there's a whole range. So we see that the data here is critical, right? Because it pulls that curtain. But then I guess that next part is, how do you get it?
Exactly. And I mean, I think this is a good point right here. I mean, this is what the data is showing us. It's suggesting this is the case. And I think there's a lot more we can do with the data we've got. But the real point is we need folks to have the data to be able to do this stuff at all. And so speaking of getting it, I'll stop here and I'll let Ben share some of the hidden insights that SenSen's come across in their work.
Perfect. Thanks, James. Yeah, this is a great segue. And I think we can build that, cross that bridge here with how we collect the data that it can be utilized for analysis. So my name is Ben Pish. I'm the VP Clients and Markets for SenSen, based here in North America. SenSen is a global AI company really focused in the parking and transportation industries. So we leverage a lot of AI models to do things such as parking enforcement and analysis for transportation, including the curbside. My background is largely within the municipal parking world, where I was in charge of many different parking programs that utilized LPR technologies and, of course, a strong focus on curbside to make sure that parking enforcement was being done correct and accurately. I think this image here is quite common for a lot of parking operators. Most people are using LPR-based enforcement. So the picture detects a license plate, matches it against, a payment, a permit, or an overtime regulation. Those are very common, very traditional. I don't think there's many cities who aren't doing some form of this right now in the world. What SenSen realized early on, probably more than 10 years ago at this point, is that parking enforcement is much more than just those three core types. So it's more than just, did I pay for parking? Do I have a permit? And have I stayed too long? What it really, extends to is, am I allowed to park there? Is there no parking sign? Is there no stopping sign? Is there a fire hydrant? Am I in a bus zone, a taxi zone, a loading zone, right? The curbs are quite complicated. Even just by looking at that sign in the image there, there's more than just one parking rule going on. There's different times of day. No stopping kicks in at a certain point. There's no parking and on and on and on. You'll notice this just on a given block face. There could be as many as 4 to 5 different regulations at any point in the day. So how do we enforce those? So SenSen has really focused on how do we enforce the whole curb, not just a specific rule. And we came up with this automated parking system, which, like I said, we've been utilizing for over 10 years now. And what it does is it enforces the rule based on the location. So it'll know based on your location or the vehicle in question. So in this case, that white vehicle, that it's in a paid parking zone from this time to this time. But maybe the rule changes at a certain time to no stopping. The system will know now that you're in a no stopping zone. If you were parked on the other side of that parking sign, it knows that you're in a no parking sign. So really you're able to look at the entire curb as a whole and enforce it as a whole as well. At the same time though, because we are acknowledging all these different rules on the street, we're also digitizing and building this fairly comprehensive curbside inventory. So we need to know what's on the street in order to enforce it. And by default, we're then collecting this information and all these curbside assets, which we may want to enforce, but it can also be used for the data side that James has been alluding to. So let's look at curbside assets from the street. James made the statement, you don't know how many parking stalls you have. And as he mentioned as well, most cities would be in the same position. And it's true. Every city that I've worked with or worked within, knowing what you have on the street is extremely difficult. It's dynamic. It's ever changing. If you did want to go and collect all that information, it's a lot of labor, a lot of time. And is it even done accurately when it's manual? So you'll notice some of these curbside assets, really. A fire hydrant's a given. Parking signage is a given. Even things such as curb cuts that are splitting paid parking or timed parking zones are an asset worth collecting. And the biggest one here, I think, that often gets forgotten about is what's occupying the parking stall. Is it a vehicle? Is it an object? Is it a garbage bin? There's so many different assets or different objects that can be occupying the on-street parking zones. So this is an example from a customer being able to build this inventory out. The number of fire hydrants, number of pay stations, single space meters, the list goes on and on and on, being able to build that information. And James, perhaps, is this information valuable? Is it a nice to have? Is it helpful?
I mean, it's critical. And in what we do, we're less concerned with some of the assets like fire hydrants, but we're very concerned with things like spaces. And when I look at this, I mean, one of the first things I saw when we talked about this before this panel was the fact that there's 178 single space meters, but there's 23,000 spaces. So you've got 178 easy to count spaces, and you've got 23,000 more that are mixed across just zones or multi-space meters, of which, it looks like there's about 10 spaces per pay station here. Figuring that number out, you can do some ballpark math again, but immediately you don't know how many spaces you truly have unless you go out there and get a count somehow. And traditionally, what we have done in the past has been, manual counts, which might cost you $50,000 to $100,000 for a city this size, maybe more, depending on the number of blocks you've got to go walk and figure out. So having this data and having it accurate and easy at hand would be is a huge win for any city that wants to get started on looking at their data.
And James, just to underscore that, I think when we were discussing this in preparation for today, you had said that effectively was so onerous to try to collect this data, or it is manually, that it just basically never gets done. You see projects that get 2/3 of the way done or what have you, and then they're abandoned. Is that accurate?
Yeah, I think it depends on the size of the city. Smaller cities get it done because they might have 1,200 spaces or 1,500 spaces. A city like this, I'd be willing to bet that is the case. Or they have to hire somebody full time who's just on it, and always going around. And that's a full time person or people who are checking that inventory. And even then, when was the last time they walked, these 10 blocks versus these other 10 blocks? It's how accurate, how fresh is that data? Do they know where there's a construction project happening, even if there's a permit in some system somewhere else? That system may not be related to the Kerbside team's system. So it's sometimes it's not done. Sometimes it's done and it's expensive. Sometimes it's halfway between.
Yeah, and I caught on to two words. I think I heard you say walk and fresh. So if you were needing to walk to collect this data, how many times can you actually do it in a given month or year? Yeah. So that ties to how stale or fresh the data is. And as we've discovered, the curve is ever changing. So what was true today is probably not true tomorrow, especially when you start looking at what is actually occupying a parking spot. That can change by the hour. Mm-hmm. So it's very, very dynamic. One of the other opportunities with collecting these assets is not only do we have the data to know what's happening, but we can then identify things such as conflicting or damaged inventory. So we know if signage is conflicting, if it's missing, perhaps pay stations are damaged, knocked over. This sort of thing usually gets caught at some point in time, or maybe not. I've seen some parking signs on the street that look like they've been there for 30 odd years, hunched over to the side. Without having a method to do this ongoing, the process does seem to fail, but there is a process, and we're going to jump into that here. So I started off with talking about LPR enforcement, and I introduced this automated way of enforcing based on your location. So imagine that the vehicle is constantly in motion. It's enforcing in real time, paid permits over time, the standard 3, but it's also looking at those other rules that I talked about. So no parkings, no stoppings, fire hydrants, because it's all digitized. The curb is digitized. It knows where it is, and it knows if a vehicle is parked where it shouldn't park. So that's the enforcement side. But there's also this collection aspect that can happen in parallel. So these assets on this slide here, imagine that same LPR vehicle doing parking enforcement is also picking out these assets on the street as it drives by. And you can notice by the side profile context image here, it's picking out signage, curb cuts, and the like. And so what you can do then is you can actually start collecting those assets, which we've deemed very labor intensive to be done on foot. You can do it in parallel with the parking enforcement vehicle. The operator doesn't even need to know that he's collecting it. He's focusing on enforcement, and the system is doing the other work through AI models. And from that, we have basically two data sources, right? We have the enforcement, and now we have these curbside assets, so this inventory for analysis. So I can go to James to run his analysis to see what's happening on the street. It can also go to departments that maybe look at damage signage, or how many pay stations do I have, or where are my single space meters. So the data can be used in a variety of different realms. But then it can also go back to enforcement. So I've collected the data, I've reviewed it, I've noticed that there's conflicting signage, I've noticed that maybe this zone doesn't exist anymore. I can feed that back into enforcement. So now when I'm enforcing, I'm disregarding those zones, or maybe I'm disregarding this area because the signage is incomplete or inaccurate. And so I'm having a better enforcement experience. I'm not issuing bad tickets. And it's this cycle that can carry on, daily. Some customers have 10 of these vehicles driving around. Some have one. So you can start to think about the amount of time that I can start collecting this data. And it's the decision of the city with how often that they want to review it. For a couple examples here, so from the automated enforcement perspective, one of our customers was able to tell us that they were able to increase their ticket issuance by 50%. That's a huge jump. That's largely down to the automation. It's down to the operator not necessarily needing to know where they're enforcing. They're just focusing on driving efficient routes, and the system is doing the enforcement for them. On the data side, a customer was able to better align their on-street assets for the customer's needs. So perhaps they had too many machines too close together. Maybe they could spread them out. Maybe their parking signage was deemed inaccurate, or maybe they had zones where they didn't need zones, or compliance was low. And so they were able to visually see what was happening on the street and make those adjustments. Yeah, James, go ahead.
Yeah, when you mentioned that, I mean, increasing the ticket issuance by 50%, it's a really interesting number. We've looked at this a little bit in the past, and in some of the compliance analysis we've done, we've seen cities maybe hitting 12% hit rates. Out of the predicted non-compliance, they're hitting 1 in 8 vehicles. And I think there's lots of reasons for that. Obviously, increasing that number is going to help a lot. It's going to increase the expected value of a ticket, which is then going to change the calculus for people who are going, well, if I park 10 times and I only get ticketed once, then it's going to be cheaper. But also, I do think that there is a lot of, I don't want to say it's directly politics, but there is some concern in cities. You don't want to look like you're sending your enforcement always to the same place and you're kind of targeting one zone, which could look biased. Maybe it's a bias towards where the non-compliance is happening, but having the data to show that, I think, could really improve the efficiency of directing enforcement, while also being able to back up that decision with something that's kind of cold hard fact, as opposed to, well, we just know that this zone has a lot of non-compliance, so we have to send people there.
Right. Yeah. And guys, can you dig a little in looking at this circle, this enforcement collection analysis circle? It feels like there's obviously, you're learning, right? You're refining. There's a process. It can't happen overnight, right? Like, to take it back to the restaurant analogy, you open up a restaurant. It takes years, right? I mean, I think, James, in fact, you have personal experience in restaurants. It takes years to get to know clientele, get to know how people interact. Is this a muscle that takes time? And what's your experience in terms of, councils, governments implementing this and that process, building the muscle?
Yeah, I can jump in. I mean, I think you're exactly right. Jonathan, if it's a restaurant, you're starting with, hey, let's just get the right offering to get people in the door before we start worrying about how fast we get them out the door to optimize. And I think it's the same here. You've got to start somewhere with one step. It's very much an atomic habits kind of a thing. Building any parking program, and I've seen this across city after city. Everybody takes, the choose your own adventure. Everyone starts somewhere, maybe a little different, but you've got to start with something. And ideally, you start with one bit of data that you can use. So maybe it is you go out and get a good inventory of your assets and your spaces, and you start there because now you know where most of them are. I mean, just with that data alone, you could start to do things like, well, we don't know what's happening in those spaces, but we know where most of them are and where the ones that are furthest apart are. And so we can be more efficient and effective in how we allocate our human resources to get to them. We'll go to the places that are the densest, and we'll do a little bit less where things are sparse because it's just going to be more walking, for example. And then you kind of build that muscle over time. Ben, have you seen kind of similar things?
Yeah, so I think there's two factors here. I think, and I'm guilty of this from my municipal days, is running off of assumptions. I assume this block face has poor compliance because of whatever reason. It's very popular. People like to park there, and vice versa. I'll assume that this place has great compliance because it's a residential area. But those assumptions aren't always true until you start enforcing it more frequently. And so what I've often found in the field is there's this low hanging fruit where from being able to, and I call it equitable enforcement, meaning in an automated fashion, I can cover more area quicker. So that means I can, instead of just getting to one neighborhood once a week, maybe I can get there 3 times a week, or maybe even once a day. And you start to realize these patterns very quickly. And compliance is something that you can usually tell very quick. Something's high or low compliance, and you can make adjustments, right? We, from experience, we used to enforce a certain part of town all day, literally all day. And until you actually look at the data, you realize that, most of the time it's wasted. And you can redirect, as you mentioned, James, you can redirect your officers or your staff to a different area. And that's where that equitable enforcement comes into play, which everyone loves. But on the other side of it, yes, building this data or collecting this data, I'll say, is maybe the easy part. AI models are great. They get refined all the time. The more you drive, the more you collect. All of a sudden you have a lot of data to sift through. So you have to have those processes in place to be able to manage it. And perhaps, James, you've come across that. Is there such thing as too much data?
Yeah, always. I mean, the average city, I think, if you look at a city that's maybe between 2 and 500,000 population, right, which is a lot of cities in North America kind of fall into that category, or even 100 to 500, you're going to see between 5 and 20,000 transactions a day, which is just parking events. We're not even talking about assets now, just the people parking on the curb or in your lots. So 20,000 events a day, go drop that into a spreadsheet and have fun, right? It's a lot. But if you know where to look first, and if you can sort of systematically test your assumptions, I think it's a great point, Ben. Like we all start somewhere with assumptions we've made, choices we've made that were like semi-arbitrary, but based on human factors. So a good example in cities is the way we define our zones, our parking like areas. And we tend to define them based on sort of demographic things like, well, this is the retail area, so we're going to call this retail, and we're just going to draw a circle around these blocks, and boom, that's the retail, and we're going to price for that. And then this over here is going to be some other, this is a school zone, so we're going to price this differently. You make those decisions, you arbitrarily draw those bounds based on good reasoning, but not database. It's just, this is roughly right. Then you test those assumptions, and you start to see that, actually the boundary of these two zones, some of these actually are behaving more like this one, and some of these are behaving more like this one. And so then you can start to refine. So you start with some assumptions, you start with really straightforward things you can do today, and then you use the data to refine it with a process like this that helps you actually filter it and understand it.
Yeah, James, thanks for that. And I just wanted to throw to the audience and say I haven't seen any questions pop up. I just want to remind you guys that it's bottom right questions, and we've also opened 2 polls, which we'd love some answers on. How accurate do you think your parking signage is? Is it accurate or not accurate? And do you know how many parking spaces you actually have? Yes or no? To go to James's earlier question. But I want to throw to Ben, and Ben, you were talking. I know you could argue you get too much data at a certain point, but when you were talking about the picture of the curb and what SenseSend does to capture that picture, could you give just a practical idea of what that looks like? Like, are these mobile cameras? How fast is data being collected? When you identify that, say curb cuts, et cetera, or that sign, how quickly is this being done?
Yeah, good question. So I think going back to LPR enforcement, people are very familiar with the speed that a license plate can be captured from a mobile camera on a vehicle driving down the road. So this is what this picture on the left is showing. Camera on a vehicle, probably traveling 30 to 40 kilometers an hour, capturing that vehicle in real time. The image on the right is also an image captured from the mobile vehicle driving 30 to 40 kilometers down the road. And it's happened right after we've captured that vehicle's license plate. So it's happening in real time, and it's happening very quickly. and it's happening without any intervention from the operator. So our models can be deployed to essentially capture anything we want. Parking signage is quite obvious, but anything identifiable can be captured from these AI models. And it'll be captured just like that license plate was captured, and then filtered, into a cloud-based process where it can be further analyzed. All the detections have GPS coordinates, so we know its location. We know the nearest zone that it's close to, and then we can extract metadata from the signs as well. So obviously, fine print written on signs can be quite challenging for AI models to extract. But if the object is identifiable from the shape or the category, it can usually be categorized that way. But there's always or typically a manual review portion. So in order to ensure, the writing is the same or the rules are the same, that might fall into a manual review. So you probably don't want to do that every day, but the data can be captured in near real time as often as you like. So that's the idea, is to basically not inhibit that data collection aspect, making it available so it can be done ongoing.
Yeah, thanks, Ben. And I know you said that one of the more surprising results was a 50% increase in ticket issuance. James, I was wondering, what have been some of the most surprising hidden assets that you've kind of revealed to some of the municipalities you've worked with?
Yeah, I mean, there was one not too long ago where we've gotten really deep into the mapping of things like meters, right? So when we work with the city, one of the first things we have to understand is, where are all those meters, the same data that Ben's capturing. And the interesting thing about meters is, they'll report home with a lat long that tells you where they are. And that's great if that lat long is programmed at the right place at the right time. The meter will tell you, yep, I'm here, and we'll know, thanks to GPS, that it's within about 3 meters of that spot. However, if you say program your meters at the meter depot and then go and deploy them into the field, they might pick up their location at the depot. And we saw exactly that in one case where we had a pile of 40 meters, all reporting to be on the same, not just the same block, but within the same 6 feet of each other. And when we went and looked it up, turned out those were all reported at the depot lot before they got deployed. So things like that, the second you look at it, if you have 20,000 transactions a day, you're never going to see that pattern in there. But once you start filtering it or mapping it or finding ways to organize it, it's blatantly obvious what's up, and it's an easy fix once you know.
Yeah, that makes sense. And it's quite surprising. So it's basically you just don't know until you start looking. I'm wondering if what collectively, what do you guys see as the biggest hurdle to adopting this sort of data-driven approach to managing and sort of enhancing curbside?
I think it's that historical method of collecting from the actual inventory side has been, in my opinion, the one that restricts it. Is everyone knows that it's beneficial to go and have, a digitized curbside, but it's the how you do it. And hiring, from my personal experience, hiring summer students typically never fully worked out. The project doesn't get done. You can't always rely on the data that's being collected. And so you get to the end of a 3-month period and you don't know whether you should actually keep it or not. So I think that's typically been the reason for not pursuing and maybe not being aware of what's available in the market. So this solution, not new by any means, but I don't know if many people are fully aware what's capable, and not wanting to invest in a separate system, but being able to run it in parallel to something they're already doing, I think opens up a huge opportunity.
Yeah, I think Ben hit the nail on the head. It definitely, there's a status quo thing of what we already know we can continue doing because it takes not a lot of decision-making power. And when you're running a curbside program, there's a million decisions to be made about a billion different things on a given day. So it's hard to, make this one. I think also awareness, like Ben said, this is still fairly new technology. For anybody who's been paying attention, we may remember Cord, which was another means of digitizing the curb and then got acquired and then got shut down. And so I think there is an awareness piece. This market is changing relatively fast, and people aren't necessarily spending all their time keeping up with it like we might be. And there has, I think, just been this hesitance to change the status quo because we always know there's summer students, but what are my options for other means of digitizing?
Yeah, thanks for that, James. And I'm wondering, in a practical sense, how does Turnstone work with cities? Obviously, there's the data collection side that we'll talk about with Ben, but like with that analysis side, how do you practically work?
Yeah, so we do kind of this combination of software and service, and that's kind of by virtue of the fact we've been in this for so long. Myself and our other co-founder Scott have been we've been doing Turnstone for 6 years now, and we've both been involved in the transportation and parking industries for decades. So what we've kind of landed on is this model that's worked really well for us, where we have a platform that once we get this thing configured and we've got the data in, we have self-serve. You can explore your data, you can pull reports, you can do what you need with it. But then we also monthly meetings with all of our cities, and we talk with them about what they're doing, what they're trying to do. And we actually do provide just this side service of giving them a chance to bounce ideas. We may help them pull some data. We kind of think about different ways to look at the curb. And it's great for us because we're at heart data nerds and we love this stuff. It's also great from a business perspective because we kind of have an idea of what is happening in parking and what maybe we could do next as a product. So there's a business win there as well. And to be honest, we really like our customers. They're good people who have really good intent. They want to better their cities and improve their programs over time. And that's something that we feel is just really worth supporting.
Yeah, no, that's good to hear, and make their restaurant better. Yeah. The Kerbside restaurant. And Ben, like practically speaking with Sensen, obviously you have to be out on the streets. You've got implementations. How does that work?
Yeah, so Sensen, as I mentioned before, a global AI company, and AI is in our DNA, research-based AI professionals within Sensen. So we largely work with municipalities, and we typically solve certain problems. So parking enforcement is one of the main problems that we solve, especially in North America. It's the examples that I previously gave. Usually a customer will come to us because they want to find efficiencies. So they've used traditional LPR enforcement, which is usually user input. What do I want to enforce? This is the option that I want to enforce. But it's very much, it's not as efficient as you could possibly get if everything is predefined and the vehicles can just drive and basically make those decisions for them. In the transportation industry, that's where we get into this curbside. So we're able to use our models to then extract this data from the curb and find those other hidden insights. So some of our other options that we provide is seeing how people interact with assets, seeing, for safety reasons or for security, you can see where people are hanging around. Are they near pay stations? What are they doing on the curb? So there's different avenues where our solutions can take us. But large in part, especially in North America, it's related to this parking and transportation world. And some of the problems, our customers will come to us, and once they get a feel for the system and how slick it works and how easily they can enforce, they're the ones that ask the questions. Well, can I do this now? Or can I do that now? Can I detect this? So we work in conjunction with a lot of our customers to enhance our models, build new models, and to add products onto our current product line.
Yeah, great. Well, thanks, guys. I think we've come to the end of our webinar. I certainly learned quite a bit, and obviously, just to recap, it's the curbside data gaps that many councils face, and the hidden costs of missing that data on enforcement, and then obviously how to begin a better data collection process and build that muscle. So, thank you everybody for joining us today. I just want to say we're going to be having a September webinar. I think is planned, and we're looking forward to that. And obviously, if anyone wants to talk to the guys, I think you're both available one-on-one to chat with anybody who has any questions. So thanks again. Thanks, James. Thanks, Ben.
Thank you.
Thanks so much for hosting, Jonathan.
Take care.